Half angle formulas. So you had video on an assignment from yesterday that had the worksheet had part of it was half angles, part of it was double angles, with same section. We'll talk about half angles now, and then you'll just basically finish the worksheet from yesterday. So whenever you have a half angle formula, basically it's just going to be a value that's going to be like 112.5. Now, the one thing it should be sine of 112.5. We'll get to that one in a second. Okay, so as far as your half angle formulas, again, you have these. They are right below your double angle formulas, conveniently. So whenever you have a half angle formula, okay, you have a square root. The big thing is it says normally with a square root you have a plus and a minus where you have two answers. Okay, that's not the case here. The reason why you have a plus and a minus is because you've got to pick which one it is. Is it positive or is it negative? It's all dependent on what quadrant it's in. Okay? And not the angle that you have, like the 112.5. You're not looking at that one. You're looking at where is the full angle at, not the half angle. Does that make sense? Okay? So the first thing you've got to do, if I have sine of 112.5, okay, really, so again, this should be sine of 112.5, not just 112.5 degrees. So whenever I rewrite this, what is 112.5? How am I actually going to write this? Like, what is my actual angle that I'm dealing with? Like, if 112 is the half angle, what's the full angle? 225. So it's really sine of 225 degrees, or sine of 225 divided by 2 degrees. Okay, so how did I get the 225? Well, I took 112.5 and I multiplied it by 2. Okay, that's where the 225 over 2 came from. So then it just becomes plugging it into my formula. It's sine of alpha over 2, or sine of 225 over 2. So then all I'm going to do is just kind of get in where it fits in. The first thing I want to do is figure out, is it positive or is it negative? So if it's 225 degrees, where is 225 degrees? Is it in quadrant 1? Is it in quadrant 2? Is it in quadrant 3? Or is it in quadrant 4? It's down here in 3. So down here in 3, then it becomes figuring out, okay, what's positive, what's negative. Remember that all students take calculus. Okay? So remember, those are the values that are always positive, so that means the other two are going to be negative, unless it's in quadrant 1 where everything's positive. So then if tangent's the only thing positive down here in quadrant 3, what is sine going to be? It's going to be negative. Okay, so whenever I do this, then everything that I have is going to be negative of the square root of 1 minus cosine of 225 degrees all over 2. So from there, then, I need to change the cosine of 225 degrees into one of those values. Either square root of 2 over 2, square root of 3 over 2, 1/2, things like that. Now, which type of angle is 225 degrees? Is it a 30? Is it a 45? Is it a 60? Is it a 90? Is it a 0 or 180 type angle?
45.
45. Okay? It only makes sense, or it should, because it's the only one that ends in a 5. Okay? hint, hint, nudge, nudge, it ends in a 5, probably going to be the 45-degree angle. Okay? And again, we're going to give you values that are going to be nice and neat and easy to work with. I'm not going to give you 49.5, and you've got to go from there. Right? Okay? We're going to give you values, or I'm going to give you values that are going to be nice and neat and easy to work with. So if I have 45-degree angle, what is cosine of 45 degrees? Square root of 2 over 2. Okay? But what does that value actually need to be since it's down in quadrant 3? It needs to be negative. So then whenever I go here, I'm going to have 1 minus negative square root of 2 over 2 all over 2. Now, your next step is really up to you as far as how you want to write this. If you're going to combine everything on top, okay, what do you need in terms of the common denominator, right? So I'm going to kind of do two things at once here. Okay, I'm going to rewrite it to where I have a common denominator. So I'm going to have the square root of 2 over 2 plus the square root of 2 over 2. And then it's all still divided by 2 underneath the radical. Again, a lot of what we do here is really just simplifying everything out because it's still not going to be, I'm still going to get an exact answer. It's still not going to look great, but I don't want any sort of decimal coming from this. So then, if I just rewrite, and I'm going to kind of overwork it a little bit, if I just rewrite 2 plus the square root of 2 over 2, and then it's all over 2. I want to at least get this down to where there's only one fraction, not 2. So, what can I do? If I'm dividing by 2, what's the same thing as is that doing if I'm multiplying? What? Multiplying by 1/2, right? Or just like keep, change, flip. So really what I'm looking at is inside of here is 2 plus the square root of 2 over 2 times 1/2. Is the top going to change? No. What's the bottom going to change to? 4. Okay. So then I have the square root of... Oh, I keep doing this. This should be a negative all the way out. I keep forgetting to put it out there. My fault. So then 2 plus the square root of 2 over 4 with the negative. Can anything simplify on top, or is everything going to be underneath the radical still? Everything's still underneath the radical, right? What's going to happen, like if I rewrite this as negative what's going to happen to that 4? Just going to become a 2. Okay. So then my final answer is just going to be negative and then square root of 2 plus square root of 2 all over 2. You can leave the square root underneath the square root, that's fine. You could make it a 4th root if you wanted to, that's completely fine too. Like you could rewrite this as the square root of 2 plus the 4th root of 2. Okay? It's not a must, but you can leave it just like this here. Alright, so I'm going to go a little bit out of order. I'm going to go to 6 and then I'll come back to 5. So whenever you have half-angle formulas for tangent, you have two things that can happen. Okay? You can either have 1 minus cosine of alpha divided by sine of alpha, or you can have it flipped and it can be sine over 1 plus cosine of whatever your angle is. Okay? Now, whenever you verify anything, okay, you're getting to the point to where you have a lot of different things. You've got a lot of different options, right? Okay? Because before we just had about 4 options here whenever we did with just sine, cosine, tangent, things like that, and then we had the Pythagorean identities. And then what happened? Well, we added sum and difference. We added sum to product. We added double angles. Okay? Now we have half angles. Okay? So you have a lot of different options here. Okay? So whenever you have a lot of different options, it's really just a matter of looking to see what can I do to try to make this as easy as possible. Okay? So in doing that, like, I don't want to change. Like, I have 2 different ways that I can rewrite tangent of alpha divided by 2. Whatever my angle is divided by 2. It doesn't do me any good to pick one to change it into until I mess with, or until I try to fix the more complicated side. Okay? Try to, if you've had me before, like if you had me in years past, that, it's work smart, not hard. So before we even try to do anything with this left side, let's try to see if we can fix the right side first, and maybe things will work out. So I don't want to really touch anything because I don't want to just throw a dart and just hope that I hit the right spot. Because what's the easiest way, like what's another way that I can rewrite cosecant?
1 minus cosine of A.
What?
1 minus cosine of A over sine of A. Or not cosecant, I was looking at tangent.
Yeah, let's just look at this one right here.
Okay.
Yeah, I don't want to pick yet, okay? Because what do I have? I either have a denominator that's just sine, or I have a denominator that's 1 plus cosine, right? What it's going to do, it's going to basically tell you which route to go. What is cosecant? 1 over sine, right? Well, that looks good. That looks promising. So 1 over sine of alpha minus, what's another way of writing cotangent? And don't say 1 over tangent. Cosine over sine, right? So if I write it as cosine of alpha over sine of alpha, I have 2 fractions. What do I need to do now in that second step? Combine it into 1. If I combine this thing into 1, then what am I going to have? 1 minus cosine of alpha over sine of alpha. Have I seen this somewhere? Maybe recently, in maybe like a yellow box with black lettering, maybe right above here. I don't know, maybe. What's the orange one going to turn into? Just tangent of alpha over 2, right? Because it fits. 1 minus cosine of alpha, 1 minus cosine of alpha, all over sine of alpha. Perfect. Okay, so then this bad boy's verified. Now, same idea with 5 in terms of anytime we're trying to verify here, is try to get things to be as easy as possible. Again, you have a lot of different options that you could go to. Worry about the more difficult side more than anything. Okay? Obviously, you could change tangent of theta into sine over cosine. Okay? And we could go that route. Okay? And you could have two fractions, and we could multiply, we could cross multiply and go with that and kind of go that direction. Okay? Probably not a great direction, just because we really don't know what to do whenever I have sine of a double angle times sine of a regular angle. Okay? It's not like it's just one plus or minus, things like that. So I want to really focus more on the right side than I do anything. Okay? And I'm going to worry more about the denominator side first, because the top side I kind of have options. Okay? And if I have options, I want to figure out what's going to be my best option. Like, there's only one way to rewrite sine of 2 theta, right? Okay? There's only one way, so if there's only one way, that's the only way that I want to rewrite it. I don't want to try to recreate the wheel and write this thing any differently. So how can I rewrite sine of 2 theta? 2 sine x, or 2 sine theta x, whatever you want to call it, cosine theta. Now, here's where you've kind of have a decision to make. I have tangent of theta over on the left side. I'm not really worried about that right now. I have 1 minus 2 minus cosine of 2 theta. What's the problem with a double angle with cosine? How many different options do I have? I have more than one. I have 3, right? Because if I look at it as far as my options that I have of cosine of 2x, the first one is just cosine squared x minus sine squared x. The other option is 2 times cosine squared x minus 1, and then 1 minus sine squared x. I have 3 options. Which option do you think I probably don't even really want to deal with before I even do anything? Which one really doesn't make a whole lot of sense, probably? The top one, right? Why not the top one? What do I need to, or let me ask this question. Let me back up a little bit. What do I need to do on the top, probably? What do I need to get rid of? Somebody. Who said it? No? No? Hill, did you say it?
I said it.
Oh, what did you say then? Oh. What do you need to get rid of on the top? The 1. Okay, I'm going to need to get rid of the 1. So if I have cosine squared x minus sine squared x, am I going to get rid of 1? Probably not. Now, I could, because I could turn, like, I could realistically do it that way. It's going to get a little messy on the top, because what can I ultimately change 1 into? What is 1 in dealing with sine squared and cosine squared? Yeah, them added together, right? Like, that could be an option. So like, if you went that route, it's probably not the best option. You're kind of detouring a little bit, okay? Got a little road work ahead, so you're going to have to go a little different direction. Like, you could do it that way. That would be okay. But realistically, I want to probably get rid of the 1. So if I get rid of the 1, the top one's probably out. Okay? I'll show you how to do the top one, but just kind of see, you know, like if that's what you want to go with, or if that's what you chose, we can still get there. Same way with the second one. Do I want to look at the second one? Yes, no, maybe. Okay. No, I hear a yes, and then Courtney's shaking her head. You? Yeah, because it's minus, right? Because what is, you've got a negative here, though. So what's that negative going to do whenever we go here? It's going to make it a plus. So again, we can still get there, but it's going to get a little messy. Okay? Because what's going to happen, so which one do I probably want to pick? Probably the third one, right? Third one's probably my best option as far as to get right there and just to go. So if I pick the third one, and I have 1 minus sine squared x, or not x, sorry, theta. What's going to happen with that negative? Distribute, so that's going to make it, it's going to make that a plus. So really I'm dealing with 1 minus 1 plus sine squared theta all over to I forgot something somewhere. Oh, I forgot the 2. That's what I did. There should be plus 2 sine. There we go. Right? I didn't write it in my formula over here. So then sine of theta, cosine of theta. What's going to happen on the top? Those go away. What else is going to go away? The 2's are going to go away. And then one of the sines are going to go away, right? So I'm going to rewrite this again. You don't have to rewrite this, but I can have sine squared theta of sine theta cosine theta. And then, just like you told me before, I'm going to end up with sine of theta over cosine of theta, which is just what? Tangent of theta.